Hello, how are you? Hope your Easter was fine. This is Mrs. Cervantes. All right, today we're going to do the guided lesson of special right triangles. There's going to be two theorems. You have it in your document. The first one is theorem 7.8. This is when you have 45, 45, and 90-degree triangles. And of course, basically, this is, we're talking about a right triangle, because it's a special right triangle, where you have 45, 45, and 90 degrees right here, okay? So, when you have a triangle like this, let me label the sides. If you have 45, 45 means this is a isosceles triangle. So this is the leg, this is the leg, and this is the hypotenuse. Okay, so if you want to copy just the triangle, you don't have to copy the whole document that I uploaded. And then this is the formula, okay? So to make it short, I'm going to use H for hypotenuse equals the leg. So I'm going to use letter L for leg times square root of 2. This is a formula, okay? When you have a 45, 45, 90 degree triangle. Okay, so I'm going to try to make this lesson in two parts because we have two theorems. Okay, all right, so these are our first two examples, these two triangles. Okay, so if you look at the triangle, it is a right triangle. Okay, and because of this right here, we know it's a right triangle. Let me focus this over here. All right, so this angle right here, we know that measures 90. And if this one measures 45, then this one also measures 45. Okay, how do we know this? Because of the sum of the interior angles of a of a triangle. The sum of the three angles inside a triangle, of course, you remember that is equal to 180 degrees. So if you have 90 degrees here, and 45 and 45 equals 90, and 90 plus 90 equals 180. This right here is a leg, and they're asking us to find the length of the hypotenuse. So we're looking for this side right here, the hypotenuse. Remember that the hypotenuse is always the side that is across the right angle. This marker is bad. Okay. All right, so we're going to use our formula that we wrote over here. Okay. Hypotenuse equals leg times square root of 2. Since we're looking for x, we're going to substitute what we know in what we don't know. All right, let me lift it up. I wrote the formula. The hypotenuse equals the leg times square root of 2. Remember, this is a formula. So remember, this is the guided. As I write, you write. The hypotenuse, we're looking for the hypotenuse. We don't know what that is the measurement. The leg measures 6 and times square root of 2. So this will be the measure of the hypotenuse. Or let's find the decimal value of this operation. 6 times square root of 2. Let me get the calculator. That will be 6 times the square root of 2. And this gives us 8.48. And this is the value of the hypotenuse. Okay? Let's do this other triangle, triangle B. Look at the legs. These are the legs. This is the leg. This right here is the hypotenuse. We know the measurement of the leg. They're the same because they're going to always be the same when you have a 45, 45 triangle, 45, 45, 90. So again, I'm going to write the formula. Hypotenuse equals leg times square root of 2. This is your formula. So let's substitute. We're looking for the hypotenuse, and of course we don't know the value of the hypotenuse, so I'm going to put an x. So substitute. The h is the x. The leg is 4 times square root of 2, and this is square root of 2. This is the value of the leg because we have it right here, 4 times square root of 2, and then times square root of 2. We're going to do this algebraically, okay, using laws. This right here, square root of 2 times square root of 2, I want you to see it with the calculator. Look what happens. Let me zoom out a little bit. I'm going to do this. Square root of 2 equals times square root of 2 equals 2. That's the answer. This operation right here, square root of 2 times square root of 2 is equal to 2. Okay? Let me put it in a okay. So what is 4 times 2? 8. And that is the value of the hypotenuse. Okay? You can test this in your calculator, and the reason because square root of 2 times square root of 2 is 2 is because of this rule. Because there's a law of exponents where this is like having square root of 2 to the square, right? Because you're multiplying times 2. And every time you have a square root and a power of 2, both cancel out and you're left with 2. All right? But then, of course, you can always do this in the calculator and you're going to get a value of 8. And this is the answer. All right? Okay. Now, let's move on to our other example. I believe we have the next theorem. Okay? So, if I'm not mistaken, you have 2 documents. Oh, we have example number 2. Let me find that example. Oh, where is it? Let me find it. Oh, here it is. Here it is. Sorry about that. Okay. Example number 2. Find the lengths of the legs. Now we're looking for the legs, okay, in the triangle. So look at this special triangle. Again, since these two sides measure the same, it means it is isosceles. And if this angle right here measures 90, it means that these two measure 45 and 45 degrees each, okay? Let me zoom it in a little bit. All right, so what are we going to do? We're going to look for the value of x and use the formula, okay? We're looking for x. This is your 90-degree angle. Here's the hypotenuse. So what are we going to do? Write the formula again. Hypotenuse equals leg times square root of 2. So the value of the hypotenuse is what? You see it right here. 9 square root of 2 equals the leg, and the leg is x times square root of 2. Okay? So in this problem, we're solving for x. Solving for x, right there. So in algebra, what do we do when we're solving for x? You want to leave the x by itself. So what do we do with the square root of 2? The square root of 2 is multiplying. So in algebra, what do you do to get rid of this? If it's multiplying, what do? You divide. Divide by square root of 2. If you divide on this side, you divide on the other side. So square root of 2. What happens with these two? They become a 1. And over here, same thing. They become a 1. So x equals what? 9. And this is the value of the legs. Okay? Alright. Okay, I'm going to stop this video right here, and then the next theorem, I'm going to upload it in the video part 2. Alright? So just make sure you check the 2 links. This is part 1, and I'm going to continue with part 2 on the next video. Thank you. Bye-bye.